Good evening, children.
Good evening, ma'am.
Good evening, ma'am.
Good evening, children. Am I audible? Good evening.
Good evening, ma'am.
Good evening, children. What about the others? Are you on there? Good evening. All right. Please help me. From where should we continue? Should we start with exercise 13.1 or have you already started? Look at your notebook and let me know from where we should continue. This is over. Am I audible, children?
Yes, ma'am.
Yeah, please tell me. Please look into your notebook, children. Open your notebook. See the last one you've done. Okay, class, use the emoji. Raise your hand. Shruti, Anish, Shreya, Lakshita, Srinivasan, Shivani, Nafi, Sudarshan, Aksharam. What about Bala, Harish and Ravya? Okay, so 9 of you, at least 9 of you have responded to this instruction. Please look into your notebook. Respond to this one too. Please look into your notebook and let me know from where we should continue. I really don't remember. Is this over? We are wasting time, children.
I'm over, ma'am.
Okay, this one.
Over, ma'am.
This one, children. This one. Is it
Yes, ma'am.
Sudarshan?
Yes, ma'am.
Thank you, Sudarshan. Thank you so much. Sudarshan, this is over, is it?
Yes, ma'am.
Okay, what about this?
From this, we need to start, ma'am.
Thank you so much, Sudarshan. Nice of you. Thank you so much.
Okay, ma'am.
All right. So a medicine capsule is in the shape of a cylinder. A medicine capsule is in the shape of a cylinder with two hemispheres stuck to each of its ends. Yes.
Ma'am, we have completed this, ma'am. We have completed all the questions in the exercise, ma'am.
I got this one also.
Yes, ma'am.
What about this?
Completed, ma'am.
This one?
Yes, ma'am.
Exercise is over, is it?
Yes, ma'am.
Shreya, is it?
Yes, ma'am.
Okay. You're sure you have all these answers in your book?
Yes, ma'am. I'm having, ma'am.
Okay. Okay, then I'm sure we have to continue from here then. This is the next exercise. Okay, children. We finished exercise 13.1. So these are the examples before exercise 13.2. So Shreya just told us that we have finished exercise 13.1. So we'll do the examples before exercise 13.2. Example 5. Shanta runs an industry in a shed, which is in the shape of a cuboid surmounted by a half cylinder. So you can look at the shed. You can look at the shed. It's cuboidal, surmounted by the ceiling is a half cylinder. Surmounted means on top of it, there is a half cylinder. On top of the cuboid, there is a half cylinder. Shanta runs an industry in a shed, which is in the shed is in the shape of a cuboid, surmounted by a half cylinder, like this. Half cylinder, not like this. Half cylinder, not like this. Not this half, not this half, not this half cylinder. Half cylinder like this. This half, or this half is what you see here. Half cylinder here. This one, the ceiling is a half cylinder. A cylinder cut vertically. Cylinder, when it's cut vertically like this is a half cylinder. Such a thing is what you find here. If the base of the shed is of dimensions 7 by 15 meters. So the length of the shed is 7 meters. The breadth of the shed is 15 meters. The length and breadth of the shed 7 and 15 meters. And the height of the cuboidal portion. So the height of the cuboid. So the length, breadth and height of the cuboid given to you. See, we have two solids here. One is a cuboid, the other one is a cylinder, a half cylinder. For the cuboid, you need LB. For the cylinder, you need radius and height. Only if you have these values, you can proceed to answer the question that's asked. Question or questions that's asked. For the cuboid, you need to know the length, breadth, and height. For the cylinder, you need to know the radius and height. So we'll gather these values first, and then we'll answer the questions. So the length and breadth of the cuboid, 7 and 15 meters. Don't write this. And height of the cuboid is 8 meters. For the cylinder, radius and height. Can you see here? Can you see the semicircle? Can you see the semicircle? The semicircle. What's the diameter of the semicircle? 7. So what will be the radius? 7 by 2 meters. See, this is that cylindrical portion, that half cylinder. And this is that semicircle. A cylinder has 2 circular ends. A cylinder has 2 circular ends. It's a half cylinder, so you find the semicircle here. This is the diameter, 7 meters. So radius 7 by 2. Height of the cylinder, you see here. This is the height of the cylinder. This is the height of the cylinder, 15 meters. 15 meters. See here, this is the semicircle, half of a circle. Diameter is 7 meters. So the radius of the cylinder is 7 by 2 meters. Height of the cylinder. See, this is the height of the cylinder. This is the height of the cylinder. This one. This one is the height of the cylinder. 15 meters. Not 15 by 2. Diameter is 7, so 7 by 2 radius. Height is 15 meters. So now for the cuboid, we have the dimensions 7, 15 and 8. Cylinder radius and height, we have 7 by 2 and 15. Now, what is that we have to answer? Find the volume of the air that the shed can hold. What is the volume of air the shed can hold? So the volume of the air in the shed is equal to the volume of the cuboid plus the volume of half cylinder. Volume of the air in the shed is equal to volume of the cuboid plus volume of the half cylinder. Cylinder is pi r square h, half cylinder half pi r square h. So that answers the first question. Find the volume of the air that the shed can hold. Next, further, suppose the machinery in the shed occupies a total space of 300 meter cube, and there are 20 workers, each of whom occupy about 0.08 meter cube space on an average. Then how much air is in the shed? So the gross volume, the gross volume of air is what you find, volume of the cuboid plus the volume of the cylinder. The net volume of air, will be whatever is the actual volume minus the, the space occupied by the machinery and minus the space occupied by the 20 workers. 20 workers will be 20 into 0.08 meter cube. So whatever volume you find here, minus 300 meter cube, because the machinery, in all, they take up a space of 300 meter cube. It's not one machine or two machine. In total, machinery occupy a space of 300 meter cube. Subtract 300 meter cube. And then the workers, 20 workers, each of whom occupy this space. So 20 into 0.08. Subtract these two values. So that will give you the volume of the actual volume of air in the shed. Yeah, please write down, children. As you write, any doubts, ask me. Just give the reference number, NCERT example 5. Take the solution. You can look into the textbook for the question. Draw the diagram. That's important. Draw the diagram. You can also leave some space for the question. If you want to write the question, leave some space for the question. Write it later. Draw the diagram and take the solution. This should actually be marked H1 because you cannot have the same letter. So this should be H1. So this will be H1. So the first answer is the volume of the air the shed can hold. That is the empty shed. If the shed is empty. The next answer is volume of air in the shed. That is, what is the actual volume of air in the shed? The first one is the volume of air the shed can hold. What is the volume of the air the shed can hold? That is if it were empty. If it were empty, the shed can hold 1128.75 meter cubed of air. But it's occupied by machinery and 20 workers. So the actual volume of air in the shed is 827.15 meter cubed. Done, children? Is it over?
Yes, ma'am.
Yes.
Anybody still writing? Please tell me. Okay. Okay. A juice seller was serving his customers using glasses as shown in the figure. The inner diameter of the cylindrical glass, was 5 centimeters. But the bottom of the glass had a hemispherical raised portion. The bottom of the glass had a hemispherical raised portion which reduced the capacity of the glass. Obviously, it should have been like this, but the bottom is not flat like this. There is a hemispherical raised portion like this. But from a distance when you see, so from a distance when you see the glasses or the glass, it looks tall. But when you actually look into the glass, or maybe if you go to this shop and have a glass of juice, you finish it and you see the bottom of the glass, you see this hemispherical raised portion. It's only then you realize, oh, this is not the, you thought the glass can hold so much of juice, but when you actually drank, you finished it so quickly. That's because the bottom had a hemispherical raised portion, which reduces the capacity of juice, which reduces the volume of the juice in the glass. Or which reduces the capacity of the glass, the hemispherical raised portion. The hemispherical raised portion in the cylindrical glass reduces the capacity of the glass. If that hemispherical raised portion was not there, if the bottom was flat, then the glass can hold little more of juice. But because of that hump there inside, there's a hump. So that reduces the capacity of the glass. If the height of a glass was 10 centimeters, find the apparent capacity of the glass and its actual capacity. Apparent is what you thought it should be. Actual is what really it is. Actual is what it is really. What is it really? It is really with the hemispherical raised portion. But what you thought? It's a cylindrical glass. It's tall, so much of juice you can drink. So apparent capacity is the capacity of the cylinder. Actual capacity is capacity of the cylinder minus the capacity or the volume of that hemispherical raised portion. When you subtract, when you take away the volume of the hemispherical raised portion, it's the actual capacity. That's the truth. That's real. When you simply find the height, when you simply find the capacity or the volume of the cylinder, that's the apparent capacity. Apparent is what you thought it was. Apparent is the volume of the cylinder alone. Actual is volume of the cylinder minus the volume of the hemisphere. This is what is it is actually. What is the capacity of the glass? It is actually the capacity of the cylinder minus the capacity of the hemisphere. It's actually this. Apparent is what it looks like. It actually looks like a tall cylindrical glass. So you think it's the volume of the cylinder, the apparent volume, apparent capacity. So you're given the radius and height. You know the radius and height of the cylinder, and you know that the radius of the for the hemisphere you need only one value, radius. For the hemisphere, there are two solids here, cylinder and hemisphere. For the cylinder, you know the radius and height, and for the hemisphere, you know the diameter of the cylinder, and the diameter of the hemisphere is the same. So they'll have the same radius. That's all. Work, children. Actual capacity is only the volume of cylinder, which is pi r square h, and you're instructed to take the value of pi as 3.14. Children, now that you can see the calculations on the screen, I'm sure nobody's multiplying. You're just writing the value from the screen. But when you're writing, please write mindfully. Just don't copy like primary students from the board. Please write mindfully, or better still read. Just give a reading. First see what is on the screen and then write down. First understand and then write. I've been telling this at least once in every class. I don't want anyone to just write like that blindly. Let's make use of the time. Any questions, children? Finished writing?
No, ma'am.
Okay.
Completed.
Yeah. One minute, children. Yeah, sorry, children. Thank you. So the next one, a solid toy is in the form of a hemisphere. You can see it in the figure. A solid toy is in the form of a hemisphere surmounted by a right circular cone. Yeah, we can see the cone on top of the hemisphere. The cone ABOC. The height of the cone, only the cone, the height of the cone is 2 centimeters. So let's write down the values. Let's write down. Please follow me. The height of the cone. For the cone, we need radius and height, okay? For the cone, we need radius and height. The height of the cone is 2 centimeters. Okay, height of the cone is 2 centimeters. What else we have? We have hemisphere for which you need the radius. And we also have a cylinder for which we need the radius and height. Radius and height. I'll use a capital H. R is, you will see that it's the same everywhere. I'll use a capital H for height of the cylinder. Or you can say H1 because we already have a H here. We know that the height of the cone and the height of the cylinder will not be the same. So you cannot use the same letter H, the small letter H. Say H1, H2 or a small letter H and a capital letter H. Please differentiate. Are we using the same R everywhere? Because we will see that the radius of the cone, hemisphere and the cylinder is the same. So you don't have to say R1, R2, R3 because the value of the radius for all the three solids is the same. Because the value of the radius for all the three solids is the same. So R for everything. But the height of the cone is less than the height of the cylinder. So small h, capital H, just to differentiate. Okay, so we have cone, hemisphere and cylinder. The height of the cone is 2 centimeters and the diameter of the base is 4 centimeters. The diameter of the base is 4 centimeters. Base of the cone is 4 centimeters. So the radius is 2. So you see that the radius will be 2 everywhere. I hope we understand that because it's 2. This one is 2. This is 4. So for the radius, this also is 4. This one is also 4. So the radius is 2 centimeters everywhere. Determine the volume of the toy. So now the height. What about the height? What is the height of the cone, children? What's the height of the cone? What's the height of the cone, children?
2 centimeters.
2 centimeters. What's the height of the hemisphere? What is the height of the hemisphere? What is the radius of the hemisphere? What is the radius of the hemisphere?
2 centimeters.
Then what will be the height of the hemisphere?
Then
Louder, Srinivasan. You're the only person answering. Louder.
2 centimeters.
2 centimeters. Okay, I'm asking you the same questions again. What is the radius of the hemisphere?
2 centimeters.
Height of the hemisphere?
2 centimeters.
Is it given that the height is 2 centimeters?
No, ma'am.
Then how do you say that the height of the hemisphere is 2 centimeters?
From the height is equal to radius in the hemisphere.
Yeah, the height of the hemisphere is equal to its radius. Now, what is the height of the cylinder? The height of the cylinder is the height of the cone plus the height of the hemisphere. See the figure. The height of the cylinder. See the figure. It's evident from the figure that the height of the cylinder is the height of the cone plus the height of the hemisphere. So the height of the cone is 2 centimeters. The height of the hemisphere is 2 centimeters. So the height of the cylinder is 4 centimeters. Let's do it again. We have cone, radius, height. We have hemisphere, radius, and we have cylinder, radius and height. it is given that the diameter of the base is 4 centimeters. So the radius of all the three figures, all the three solids is 2 centimeters. Now coming to the height of the cone is given directly. Height of the cone is 2 centimeters. Height of the cone is 2 centimeters. The height of the cylinder, you read the question, is not given anywhere. The height of the cylinder is not given. But we know that the height of the cylinder is the height of the cone plus the height of the hemisphere. The height of the cone is given 2 centimeters. The height of the hemisphere is equal to its radius, 2 centimeters. So the height of the cylinder is 2 plus 2, 4 centimeters. Height of the cone plus the height of the hemisphere is the height of the cylinder. Now we have all the values. What's the difficulty? Nothing. If the right circular cylinder circumscribes the toy, exactly what you see in the picture, the cylinder circumscribes like a circumcircle, a triangle and a circle outside it is a circumcircle. So outside the toy there is the cylinder, so it circumscribes. The cylinder circumscribes the toy. That means the toy just fits into the cylinder. That means the toy just fits into the cylinder. There is no gap in the sides. The height also, the total height is just equal to the height of the cylinder. The toy just fits into the cylinder. Find the difference of the volumes of the cylinder and the toy. Find the difference. So you should subtract. What should you subtract? Volume of cylinder minus volume of toy. Find the difference of the volumes of the cylinder and the toy. So you should find volume of cylinder minus volume of toy. Volume of cylinder easy. Toy is also easy because volume of toy is volume of hemisphere plus the volume of the cone. That's all. Find the volume of the cylinder, volume of the toy, and find the difference. Write the cone first, children. Please write the cone first, hemisphere, and then in the end you write the cylinder. Write it in this order. The order I explained, First you write about the cone, then write about the cylinder. I'm sorry, hemisphere, and then the cylinder. Done, children?
No, ma'am.
Okay. Class, lower your hands. Lower your hands and raise your hand again. Lower first, all of you. Lower your hands. Please lower first. Yes, class, raise your hands. Darshan, Shriya, Anish, Rakshan, Shivani, Srinivasan, Aksharam, Shruti, Arnab, Nafi, Manasa, Lakshita, Nivedita, after a long time, Balharish, Ravya. All right, good. Nivedita, you were caught up with the exams at school, is it?
Yes, ma'am. I had my term exams.
Good, good. Okay. All went well?
Yes, ma'am.
Good. All right, children. Yes. Please continue with this answer. Let me know when you're done.
Completed, ma'am.
All right. So first the volume of the toy, which is the volume of the hemisphere plus the volume of the cone. Hemisphere 2 by 3 pi r cubed. Cone 1 by 3 pi r square h. You can see I've got both the answers in pi and then use the value of pi 3.14. That's the instruction in the question. Take pi is equal to 3.14. Cylinder pi r square h. We need to find the difference of the volumes of the cylinder and the toy. So volume of cylinder minus volume of toy, which is 25.12 centimeter cube. Yeah, take a screenshot, children. This is similar, so you can try this yourself. Please take a screenshot. Or maybe I will not explain this. Do it now in the class. I'll not disturb you. Please read the question and help yourself. Please work this now in the class. Read the question. Done, children?
Yes, ma'am.
Okay. Yeah, this one also. Please read the question. This is again simple enough to understand. Yeah, I hope you're done reading the question. So this model is in the form of a cylinder with conical ends. This model is in the shape of a cylinder with two conical, I don't have to say two, but with conical ends. It's a cylinder with conical ends. For the cone, the radius and height is given to you. You know the radius and the height of the cone. It's given directly. If each cone has the height of 2 centimeters, and you can also see the diameter of the model is 3 centimeters. Diameter of the model meaning the diameter of the cone and the diameter of the cylinder. The diameter of the model meaning the diameter of the cone and the diameter of the cylinder, 3 centimeters. So for the cone, the radius is 1.5 centimeters and the height of the cone is directly given 2 centimeters. Cylinder, radius again 1.5 centimeters, height of the cylinder. The height of the model is 12 centimeters. Model's height is height of the cone plus height of cylinder plus height of cone. The height of the cylinder is not given. The height of the model is given. The height of the model. What makes the height of the model? Height of the cone plus the height of the cylinder plus the height of the cone. The height of the model from here to here, the height of the model is 12 centimeters. What's the height of the cone? 2. What's the height of this cone? 2. So the total height 12 minus 4, 2 plus 2, 4. The total height of the model minus the height of the 2 cones will be the cylindrical height. So the cylindrical height is the total height 12 centimeters minus the height of the 2 cones, 2 plus 2, 4. That's all. Once you are able to write these values correctly, of course you should know the formula. The rest is easy. Just substitute the values in the formula and nothing much calculation. So radius is given straight away. Height of the cone is given. The height of the cylinder is the height of the model minus the height of the 2 cones. So we need to find the volume of the air. Find the volume of air contained in that model. The volume of the air will be the volume of the cylinder plus volume of 2 cones. Volume of cylinder plus the volume of the 2 cones. Cylinder pi r square h, pi r square h, pi r square h. two cones. So 2 into 1 by 3 pi r square h. Again h, so differentiate. Small h, capital H, or h1, h2. R has the same value, so you can say R. So again, here I've not used the value of pi 22 by 7. So find the answers in pi and 21 pi. The volume of the air in the model is 21 into 22 by 7, 66 centimeter cubed. Please read the answer first. Read the answer, understand the answer, and then write down. Children, is it over?
Yes, ma'am.
Yes.
Okay. Any difficulty in finding the values for the cone and cylinder, children? See, don't worry about all this, okay? Like, how do I know that this should be capital H, this should be small h? Don't worry about all that. You can just call it H1 and H2. I sometimes go with the, not sometimes, wherever I have used a small h and capital H, so small h is for the smaller value and capital H is for the larger value. So h is 2 centimeters, h is 8 centimeters. So capital H for 8, small h for 2. Again, it's easy to use H1 and H2. You know that cylinder has height, cone also has height. So just say H1 and H2, that's all. And in the formula also, pi r square H1 you must say, 1 by 3 pi r square H2. Because you have called H2 as the height of the cone. So modify the formula. pi r square h1 because you have called the height of the cone h1. 1 by 3 pi r square h2 because you have called the height of the cone h2. Here I have used this so you can see the formula pi r square h 1 by 3 pi r square h. See, after doing all this, if you say by mistake height of the cylinder, I took it as 12 centimeters. That means you did not read the question. You were not attentive while reading the question. You shouldn't make such mistakes. I saw 12, so I thought length of the model means the height of the cylinder. Length of the model is the length of the model. And the model is the cone, cylinder and cone together. The model is the cone, cylinder and cone together. So height of the model means end-to-end height. But cylinder is only this height. Yes, children, this also. Go through the answer. Read the question, go through the answer. And then write down. I think I left you with this one for a very long time, children. Is it over?
Yes, ma'am.
Yes, miss.
Okay. So the gulab jamun is cylindrical with hemispherical ends. The gulab jamun is cylindrical with hemispherical ends. And again, you see the diameter is given. The diameter is 2.8. The diameter is 2.8. So the radius is 1.4. The radius is 1.4. The radius of the cylinder as well as the radius of the hemisphere. The radius of the hemisphere as well as the radius of the cylinder. Both 1.4 centimeters because diameter 2.8. The length of the sweet is given to be 5 centimeters. See here? Each shaped like a cylinder with two hemispherical ends with length 5 centimeters. The length of each sweet is 5 centimeters. The length, and you can see it here. This figure is not given in the book. This is the part of the answer. This figure is a part of the answer. This will not be given to you. This you have to make. This figure is a part of the question. You can see it below the question. Solution and this figure is a part of the answer which you have to make. The length of the sweet is 5 centimeters. So the length of the cylinder will be the total length of the sweet minus, the length or the height of the hemisphere at this end and the height of the hemisphere at this end. And you know that the height of the hemisphere is equal to its radius, So 5 minus 1.4 minus 1.4. Will be the height of the cylinder. See, these values are important. So radius of the hemisphere. For hemisphere, we only need the value of R. For cylinder, we need R and H. This is the radius of the cylinder. This is the height of the cylinder. Height of the cylinder. This is the length of the sweet. The entire gulab jamun. So the volume of one gulab jamun will be the volume of the cylinder plus volume of two hemispheres. One cylinder, two hemispheres. One cylinder is pi r square h, two hemispheres, 2 into 2 by 3 pi r cubed. Then substitute the values and you get the value of, the volume of one gulab jamun in terms of pi. The calculation is quite, like I should say messy. It's all with decimals and all that. So you have to be careful. See now, if you have a question, where do we take the value of pi as 22 by 7 and where not to? There is nothing like that. You can, whenever it's a combination like this, when you have to find, see here pi r square h plus again 2 into 2 by 3 pi r cubed. So you can find the answer in pi. You can find the answer in pi and once for all use the value 22 by 7. Or if you feel, like see here, if you feel I'll use 22 by 7 here because I can cancel 7 and 1.4, you can do that. Here also, you can use 22 by 7, so you can cancel 7 and 1.4 because 1.4 is exactly divisible by 7. You can take it. So sometimes you can also decide like that. I think I mostly find in terms of pi and then use a value 22 by 7. So how else you can decide is? How else you can decide is just visualize the value 22 by 7 and see if there's any multiple of 7 here. If there's any multiple of 7. If you find a multiple of 7, so you can simplify, you can cancel off, you can remove the 7 from the denominator. If you find a multiple of 7, then take 22 by 7. If you don't find a multiple of 7, then you can, have it as pi and then use the value 22 by 7. So maybe in this case, you can use 22 by 7 here. So you can cancel. Not 1.4 square, children. So you should write it as 1.4 into 1.4. You cannot cancel 7 and 1.4 square. So write it as 1.4 into 1.4 and cancel. Okay, so I found the volume of one gulab jamun, and then the volume of 45 gulab jamuns will be 45 into volume of one jamun and the value of pi 22/7. This will be exactly divisible. This is not an approximate value. This is exactly divisible. See, 3 15 times, and 7 ones are, I think 7. We see here 7 ones are 7. 3s are 21. 21.2 is a remainder. 7 4s are 28. 1 is a remainder. 7 1s are 7. 4 is a remainder. 7 6 are 42. So this one is exactly divisible. This is exactly divisible by 7. And this one gets cancelled. So the volume of 45 gulab jamuns is what you see here, 1127.28. So first is about, writing these values carefully. Then the volume of one jamun is volume of cylinder plus volume of 2 hemispheres. We got it in pi. This is for one jamun. 45 jamuns will be 45 into this, and the value of pi 22/7. Now it's given that the volume of the syrup is equal to 30% of the volume of the jamuns. See here, a gulab jamun contains a sugar syrup up to 30% of its volume. Whatever is the volume of the jamun, 30% of that is syrup, sugar syrup. It's given up to, but so you have to take 30%. So up to 30%, maybe 25%, 26%. So up to 30%, not more than that. A gulab jamun contains sugar syrup up to 30% of its volume. Find approximately how much syrup would be found in 45 jamuns. So this is the volume of 45 jamuns. How much syrup will be found? 30% of its volume. So 30% of the volume of 45 jamuns, which is this. 30% of its volume. 30% means 30 by 100. Of its volume meaning volume of one jamun. Volume of one jamun. So we have found the volume of all the 45 jamuns and into 30%. This is the volume of all the 45 sweets, and 30% of their volume is the volume of the syrup. It's a very simple answer. You'll only get tired calculating. So volume of one jamun, volume of 45 jamuns, 30% of the volume of 45 jamuns will be the volume of the sugar syrup. 30% means 30 by 100. Off means into. 30% is 30 by 100. Off means into. And the volume of 45 jamuns is the volume of the sugar syrup. Yes, please read the question. I'll explain. You read the question for yourself, understand the answer, complete the answer. Once you finish, I'll explain. We'll wind up the class with this one, children. We'll finish this and then wind up the class. Please work this. So in this question, we have to find the volume of the wood in this stand. We have to find the volume of the wood in this stand. So this stand is basically a cuboid. It's a block of wood. It's a cuboidal block of wood with 4 conical depressions to hold the pens. We have to find the volume of this block. This is a cuboidal block of wood. Its volume is LBH. But the entire volume LBH is not available. There are 4 conical cavities. There are 4 conical cavities. So the volume of the wood in this stand, the volume of the wood in this stand is the volume of the cuboid minus the volume of the 4 conical depressions or the 4 conical cavities. One cone is 1 by 3 pi r square h. 4 cones, so 4 into 1 by 3 pi r square h. So the volume of the wood in the stand will be the volume of the cuboid minus the volume of the 4 conical depressions. I think the other values are given to you straight away. The dimensions of the cuboid is all given straightforward. Radius and height all given straightforward. Now the question to the class is, what is the total surface area? What is the surface area of this block? Tell me the expression like this one. What is the expression? What's the equation to find the volume of the wood in the stand? Volume of wood in the stand is volume of cuboid minus the volume of the 4 conical depressions. Now tell me the expression which will help you to find the surface area of this block. Or if you have to paint this block, what is the total area that is to be painted? Give me the expression for that. In words, I want the expression in words. Yes?
5 sides of a cuboid plus the 4 cones CSA, ma'am.
That's all?
Minus and then plus the top face minus the 4 bases of the cones, ma'am.
Very good. Perfect. Okay. We'll just give others some time to think. What is the area? Look at this block. Where all will you paint? Where all will you paint? You have this block and a brush in your hand. All those areas where you have to, paint up, use the brush, is the area of the block. So the 5 surfaces, of the, a cuboid has 6 surfaces, 6 rectangular, faces or surfaces. Of the 6, 5 are intact, 5 are not disturbed. 5 faces are intact, not disturbed. So you can call the 5 faces, you can say area 4 walls. So 2 of L, 2H into L plus B. Please listen, class. So you can say 2H into L plus B plus the area of the base plus the base area L into B. This is the area of 5 faces. This is the area of 5 faces of the cuboid. The area of 4 faces, 4 side faces, 2H into L plus B. The area of 4 side faces, 2H into L plus B. 2H into L plus B is the area of the 4 side faces and the bottom face, L into B. Now on the top face, we actually should have an area of LB. But we don't have the 4 circles. The 4 circles have taken away some area on the surface. On the surface, The area of the 4 circles are missing. So minus 4 pi r square. This is the area remaining on the top face. On the top face, the total area is actually L into B. But what is missing? This entire area is not available to be painted. The mouth of the cone is circular. So that circular portion on the top is missing. So LB minus 4 pi r square. This is the area remaining on the top face. This is the area remaining on the top face. So this is the area, this is the total area of the 5 faces, the 4 side faces and 1 bottom face. This is the area of the top face. The top face. Total area is LB minus what is not there. 4 pi r square is not there. So that means you would have painted up all this and the top portion here. This one minute. So these two expressions, you would have painted up this portion. Okay, and the others are not visible. And the top face, you would have painted this. On the top, you would have painted this. Like this. But you're not done. The conical cavities are still not painted. The cavities are not painted. The conical cavities are not painted. So there are 4 conical cavities. And the cavity has only the CSA of the cone, curved surface area, pi RL, 4 pi RL. So all this is the area available to be painted. All this is the area available to be painted. So when it's volume, it is the bigger volume minus the smaller volume. When it's area, it's not the area of the cuboid minus the area of the 4 cones. It's not like that. When it's area, it is not surface area of the cuboid minus surface area of the cone. It's not like that. Areas, you'll have to find the area of every surface that is available to be painted. So 5 faces, 4 faces, 2H into L plus B. Bottom face LB. This makes 5 faces. This is the area of the 5 faces of the cuboid. On the 6th face, this is the total area, but of this area, this is missing. 4 pi r square area is missing. Pi r square is the area of 1 circle into 4 for 4 circles. This is missing. So LB minus 4 pi r square is the area of the top face. But this is not it. The 4 conical depressions also have some area to be painted. The CSA of the cone. This one is this portion, the area of this part. The area of this part on the top face. This part. Now the conical cavities also have to be painted. Area, the CSA is available to be painted. So CSA is pi RL, 4 cones, so 4 pi RL. So you can find these areas separately and add everything. That will be the total area to be painted or the total surface area of the cuboidal block or the stand. The TSA of the stand is this one. The total surface area of the stand is what we have just understood. Is it fine, children? Have you understood?
Yes.
Class, lower your hands. Shriya, Rakshan and Manasa, are you there? Lower your hands. Not in the meeting, simply logged in. Huh? Okay, okay, Shreya, all right. Now answer this question, children. A golf ball, it's a different one. A golf ball has 200 hemispherical depression on its surface. I cannot draw it correctly. I don't know how many. I'll try. I think it's difficult to draw. Okay, let me just explain that. I'm just describing a golf ball. A golf ball is spherical with 200 hemispherical depressions on the surface. The surface is not, it's not smooth. The surface of the golf ball is not smooth. The surface of the golf ball has 200 hemispherical depressions. So like the surface will be like, I can't make it a perfect circle, children. It looks like a rugby ball. It's a circle, okay? The surface of a golf ball, has 200 hemispherical depressions. The golf ball is spherical. The surface of the ball is not smooth. The surface has craters, depressions it has. How many depressions? 200 depressions. What is the shape of each? How do the depressions look like? The depressions are hemispherical. How many hemispherical depressions? 200. Like you have a dimple on the chin. Like a dimple on the chin. The golf ball has 200 dimples. Each dimple is a hemisphere. Now tell me the area of the ball exposed to the surroundings. What is the area of the ball exposed to the surroundings? What is the area of the ball exposed to the surroundings? What is the surface area? Imagine you have to paint up this, there is something made of wood which looks like this. What is the total area to be painted? What is the total surface area of the ball exposed to the surroundings? Yeah, what is the expression for this? Yes, class. Is my question clear? Have I described clearly?
Yes, ma'am.
Okay. What is the total surface area of a sphere? What is the total surface area of a sphere? What is the total surface area of a sphere?
4 pi r square.
4 pi r square. 4 pi r square. This is the total surface area. But 4 pi r square is the area only if the ball is smooth. There are 200, what 200 are there on the top of the ball? What is the mouth of the hemisphere like? What is the mouth of a hemisphere like? The hemispherical depressions would have made 200 circles on the top of the ball. One hemispherical depression carries one circle. One hemispherical depression carries one circle on the top. 200 hemispherical depressions, 200 circles. On top, on the surface of the golf ball, 200 circles are missing because of the hemisphere. This portion, there's no material on this portion. Because there's a depression, there's no material here. So on 4 pi r square is the TSA of the sphere minus the area of 200 circles minus the area of 200 circles caused by the 200 hemispherical depressions. Pi r square is the area of one circle. 200 depressions. So 200 circles are open at the top. So that area is missing on the surface of the ball. So 4 pi r square minus 200 pi r square. But again, there is that hemispherical depression. That there is area. This area is not there. But what area is there? Plus 200 into 2 pi r square. The CSA of one hemisphere. CSA of a hemisphere. This one. This is the CSA of the hemisphere. This one. 2 pi r square. The depression has area. The curved surface. The depression has CSA. But the depression makes a circle on the top, which is open. A golf ball is spherical with 200 hemispherical depressions, 200 dimples, 200 hemispherical dimples. The surface area of the ball is, the surface area is actually 4 pi r square, but 204 pi r square, but 200 circles are missing on the top. So minus the area of 200 circles, 200 pi r square. Each hemisphere has area here, which is 2 pi r square, which is 2 pi r square. CSA of hemisphere. CSA of hemisphere is 2 pi r square. CSA of a hemisphere is 2 pi r square. So 200 hemispheres, 200 into 2 pi r square. Plus this is there. This is not there. What is not there, you subtract. What is there, you add. What is there, you should add. What is not there, you subtract. This is there. But in this one is not there. This one is not there. But this one is there. 200 into 2 pi r square is there. So this works to 4 pi r square minus 200 pi r square plus 400 pi r square. So on simplifying, 4 pi r square minus, what's this? Oh, plus 200 pi r square. It's 204 pi r square. It's 204 pi r square. Do we understand, children?
Yes, ma'am.
No response?
Yes, ma'am.
Yes.
Okay.
Ma'am.
All right. First, you should consider the total area. The maximum area the golf ball can have is 4 pi r square. From this, you should start subtracting and adding what is there and what is not there. See, when you say golf ball, the total is 4 pi r square. In this, whatever is missing, you subtract. Whatever is extra, you add. Okay, we'll see this again tomorrow. I'll not repeat the explanation now and bug you. It's time also. We'll repeat this tomorrow. All right, children. So that's it for today's session. Thank you so much. Good night.
Thank you.
Thank you, children. Good
Thank
night. Thank you. Good night.